And we're now recording. All right, looks like this is working for now, which it wasn't last Friday. All right, folks, we're down to 2 last weeks. Even with last Friday's mishap of not doing any lecture, it's still okay. I have plenty of leftover days. So I think I can still be on schedule. I was originally going to sneak in some of 5-4 Friday, but I wasn't able to, but that's okay. I can just follow this. Okay, we're not changing the exam date. So if, it's a big if, but if I can follow this schedule, 2 days for 5-4, 2 days for 5-5, you get your last quiz on Friday, then I'll start reviewing for the final exam Monday and Tuesday. Okay, Wednesday, the usual question and answer before exams. Thursday is the last regular exam. And Friday, I'll talk about the exam 5, and then you know how to study for the final exam. Reminder, on Friday the 21st, I'm not guaranteeing I can get you back your graded exams by the 21st. Now we'll go over the exam so you'll at least have the answers with you. And then hopefully by the weekend, I would get you your individual score. Okay. Again, please notice our final exam is on Monday the 24th, 8:10 to 10:40. Best way to study for the final exam is to study the old exams, of which I would begin reviewing hopefully Monday and Tuesday. So I'll do maybe a couple exams each day. And then exam 5, I'll review that with you on Friday. Okay. And again, as far as cheat sheets are concerned, you can just bring all the formula sheets from before. So the formula sheet for the first test, second test, third test, fourth test, and the fifth test, you're still building together, I suppose. Just bring them all together for the final exam. Okay. If you lost it, you threw it away or whatever, you can reconstruct it. If you say to yourself, I wish I put such and such a formula on the formula sheet back when I took test 2 or whatever, you can do it now. You can add to it. That's certainly allowed. Okay, and then we're done. And that'll be it. Okay, the homework rule still applies for the test on Thursday. So test on Thursday the 20th, you have to submit 4.9 to 5.5 for homework. Not so for the final exam. Final exam, there's nothing to turn in for homework. You just do the final, and that's about it. Okay, you should not skip the final exam. Even if you've done well all the way through, it's to your best advantage to do well. And in fact, even if you're doing well the entire semester, it's to your advantage to do well on exam 5 also, even though you have to drop policy. You can drop part of the final exam, as it turns out. Okay, so that's where we are. I will get started with 5.4 today. Let me check the chat. Okay, did we turn in 4.9 for the last exam? No, you didn't have to. If you did, just resubmit it for this. 4.9 is technically considered part of what I'm considering part of chapter 5. It was on anti-derivatives, and we did that. Okay, so you should submit 4.9 to 5.5 for this upcoming exam. Again, please note the exam's on Thursday. So I don't want to have it on Friday, then I don't get a chance to meet with you before the final exam. At least we have 1 day to meet you, for that. And we'll talk about the exam 5. Okay, so any other general questions before we go on? So we're almost done, folks. We're down the last 2 weeks, and then our final exams on the very first day of finals, Monday the 24th. Okay, please notice the starting time is 8:10 to 10:40. Okay, so if you want to join at the usual time of 9:10, I'll let you, but that means you only get an hour and a half instead of 2.5 hours. I'm not giving you more time. In fact, I have to stop because I'm giving another final exam right after that. So 8:10 to 10:40, that's our scheduled time for the final exam. Okay. All right, and yeah, anybody who just joined, put your name in the chat, and I'll get you for attendance a little bit later. I think we're good now. Okay, any other quick questions before we get started with 5.4? 5.4 is not really a new section. It's just combining indefinite and definite integrals. And you already know how to do each. You just have to recognize what to do for each one of those. Okay. How many questions are on the final? Most likely 15 or 20. Okay, 5 times 3 or 5 times 4 is what I was going to say. Okay. And any other questions anybody wants to ask when we start? So if you can do all the problems from the previous exams, you should be okay, because I'm just going to pick, 3 questions or 4 questions from each exam and give you something like that for the final exam. Okay. All right, so we'll get started. 5.4. Don't worry too much about the title. It's basically indefinite integrals and definite integrals combined, and you now know how to do both. So if I just show you the homework, show you what we have. In fact, I should mark off 5.3. So we're down to just 5.4 and 5.5. So 5 to 43 odd, 49, 59, 61. Page 408. Starts off with indefinite integrals. There's no numbers by the funny looking S. Right? And then after a while, there are definite integrals. There are numbers by the funny looking S. So you still anti-differentiate, integrate in each case. For the indefinite integral, you have to remember that the answer is blah, blah, blah plus C. For definite integrals, the answer is a real number. Plug in the top number, plug in the bottom number, and subtract. Okay, let's see, that was 49. And what else? 59 and 61. 59 and 61. And there we go. Okay. All right. So it really shouldn't be too bad. I do want to refer you to a table on page 403, table of indefinite integrals. You can put it on your cheat sheet or not, but if you stop and think about it, they're just backwards from the rules that you had for derivatives, right? So it says a table of indefinite integrals. Integral of a constant times a function is a constant times the integral of the function. Okay, integral of k is kx plus c. You know what you're essentially doing? You're taking the right-hand side. If you take the right-hand side and differentiate, you get the left side, don't you? Right? Integral of a sum is the sum of the integrals, right? And then looking over here, the power rule, x to the n plus 1 over n plus 1 plus c, n is not equal to -1. Integral of x to the n. Integral of e to the x is e to the x because the derivative of e to the x is e to the x. Integral of the sine is negative cosine plus c because derivative of negative cosine x is positive sine x. Integral of secant squared x dx is tangent x plus c because the derivative of tangent x plus c is secant squared x, right? So the derivative of the right-hand side is the left side. Therefore, the integral of the left side is the right side, right? So 1 over x squared plus 1, inverse tangent, sinh and cos. And then on this side, integral of 1 over x dx is ln, absolute value of x plus c. Integral of b to the x divided by ln b, because when you took the derivative was b to the x times ln b, right? So when you anti-differentiate, you just do the opposite, b to the x over ln b. Integral of cosine is the sine. Okay, so you have to be careful whether you're going to derivative or anti-derivative direction, right? The integral of the cosine is not negative sine. The derivative of cosine is negative sine. The integral of cosine is sine because the derivative of the sine is a cosine, right? And then you see cosecant squared, negative cotangent, cosecant cotangent, negative cosecant, 1 over radical 1 minus x squared, inverse sine. Right? Again, because the derivative of inverse sine x plus a constant is 1 over radical 1 minus x squared. Integral of cos is sinh because the derivative of sinh is cos, right? Right, so it's not really that different of a section. You just have to make sure, am I doing a definite integral or indefinite integral? And the difference being for indefinite integrals like 7, 8, 9, 10, okay, what makes it indefinite? There's no numbers by the funny looking S. So you have to know what the form of the answer is. The form of the answer for indefinite integrals is blah, blah, blah plus C. For definite integrals, And the way I remember definite integrals is there are definite numbers, right? Like -2 to 3, 0 to 3, 1 to 4, or whatever, right? Your final answer is a real number. You still integrate, you plug in the top number, you plug in the bottom number, and then you subtract. Okay. All right, so I'll get going with showing you a bunch of them. Okay, and here we go as usual. Okay, 5.4, number 5. Integral of x to the 1.3 plus 7x to the 2.5 dx. Okay, first, is this considered a definite or indefinite integral? And how do we know? Look right over here. No numbers here and here. It's called an indefinite integral. Okay, so remember, a definite integral has definite numbers. So my answer is going to be blah, 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 plus c. Okay, this should be pretty easy. Just do the power rule. So x to the 2.3 over 2.3 plus 7x to the 3.5 divided by 3.5. Okay, you can't do anything with this, but it turns out 7 divided by 3.5 is exactly 2. So best answer, x to the 2.3 over 2.3 plus 2x to the 3.5 plus a constant. Okay, so for indefinite integrals, your answer is a class of functions, a whole bunch of functions that differ by a constant. Okay. And remember, how can you always check your integration? Differentiate. Let's try it. What's the derivative of this? Now, the coefficient can be thought of as 1 over 2.3, right? So 2.3 comes down, knocks out the 1 over 2.3, so the coefficient's 1. And then x to the 2.3 minus 1 is 1.3. There it is. Plus, what's the derivative of this? You go 3.5 times 2, which is 7, right? X to the 1 less than 3.5 is 2.5. It works. And of course, the derivative of any constant is 0. So we're good. Okay, number 9, perhaps to emphasize again, there's no such thing as a product rule for integrals. There's no such thing as a quotient rule for integrals. So you have to do some other tricks. Now, in this case, the easiest thing to do is just multiply it all out. Okay, again, a major topic of Calc 2 is how do you integrate products and quotients? Okay. Now, we know how to differentiate products and quotients easily. We have a rule that will always work, right? So if you have f times g to take the derivative, then you know what to do, right? F g prime plus g f prime. If you have a quotient, something divided by something, right? F over g, you can always go g f prime minus f g prime, all divided by g squared. Okay. It doesn't work like that for integrals because there's no rule in general. Nobody's been able to find any rule for products or quotients for integrals. So we have to do some other trick. In this case, the trick is just multiply it out. Okay, so you just basically FOIL it out, and then after that, it's pretty straightforward. Okay, so FOIL this out. 2u squared plus 9u plus 4. So here we go. 2u cubed over 3 plus 9. Remember, u is like u to the 1. So 9u squared over 2 plus 4u plus c. And there we go. Okay, then the next one I wanted to show you was 21. Take a look at this integral. Is this one considered definite or indefinite? And how can we tell the difference? There are numbers here. Okay, so a definite integral has definite numbers. So is my final answer going to be blah, blah, blah plus c? No, it isn't. The final answer is going to be a real number. Okay. Oh, I still integrate. So I integrate. This time you don't need a plus c. Plug in the top, plug in the bottom. Next, subtract. Okay, so x cubed over 3 minus 3x. Don't need a plus c. Funny looking s moves over to the right side and straightens out. That's considered proper, so I want to see you can write it properly. So if you don't write the math properly, I can take off points for that. Okay, so this is Fundamental Theorem of Calculus Part 2, FTC 2. And in case you're wondering, from here on out, and for Calc 2 and Calc 3, you almost never use FTC 1 anymore, Fundamental Theorem of Calculus Part 1. You needed it for the proof of FTC 2, Fundamental Theorem of Calculus Part 2, but after that, you pretty much just use FTC 2. All right, paren, plug in 3. Paren, plug in -2. Okay, 3 cubed is 27. 27 divided by 3 is 9. Minus 3 times 3, which is also 9. So that becomes 0. That's nice. Minus. Plug in -2. -2 cubed is -8 over 3. And then minus 3 times a -2 is a positive 6. So that's nothing, but it's minus, right? You distribute negative parentheses. So that's positive 8/3 minus 6 over 1. So common denominator is 3, multiply that by 3, multiplied by 3. 8 minus 18 is -10. -10/3 is my answer. Okay. So the problem's finished, but just stop and think about what's the meaning. Do you recall what's the meaning if my integral comes out to be a negative quantity? There's more area below the x-axis than there is above the x-axis, right? For instance, I can even tell right now what happens when you plug in -2. -2, 4 minus 3 is 1. Okay, so that's positive. Okay, when I plug in 0, I get a negative. So it looks like part of the time it's positive, part of the time it's negative, right? Negative and positive. And evidently there's more area below the x-axis than above. The net result is -10/3. Okay. All right, here's 27. Integral from 0 to pi of 5 e to the x plus 3 sine x dx. Okay. Definite integral. There are definite numbers. So therefore, I mean, it looks almost the same as these. These look the same. It's got some function and the dx stuff or du or whatever. But here, the answer is a bunch of functions, blah, 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 plus c. Here, the final answer is a real number because you're going to plug in. And it represents the signed area. Okay. So we anti-differentiate, big word, integrate. What's the integral of 5 e to the x? 5 e to the x. Because the derivative of 5 e to the x is 5 e to the x. What's the integral of 3 sine x? -3 cosine x. Okay, the funny looking s migrates over to the right side, straightens out 0 to pi. And double check, what's the derivative of 5 e to the x? Same thing. What's the derivative of -3 cosine x? It's -3 times negative sine x, which is +3 sine. So you know it works. Right? So remember, you can always check your integration by differentiation. Okay, paren, plug in pi. Paren, plug in 0. It's fundamental theorem of calculus part 2. Okay, so plug in pi, 5 e to the pi minus 3 cosine pi. Side note, cosine pi is -1. Minus plug in 0. E to the 0 is 1. 1 times 5 is 5. Minus 3 cosine of 0. Cosine of 0 is 1. So it's 5 e to the pi. Let's see, -3 times -1 is a +3. And then distribute -5 plus 3. Right, -3 times 1, double negative. So 3 plus 3 is 6, minus 5 is 1. So final answer, 5 e to the pi plus 1. Okay, I'm finished with this piece of paper. So let me do my focus thing again. All right, so make sure you can distinguish between an indefinite integral and a definite integral, right? Okay, number 11. Integral of 1 plus radical x plus x over x to the 1. It's a quotient. Okay, now you might say, why don't you just do the quotient root? There is no quotient rule. Right? So what do? I'll just divide it. Do 1 divided by x, radical x, which is x to the half divided by x, and x over x. So 1 over x is just 1 over x. Square root of x is x to the half, right? X to the half divided by x to the 1 is negative x to the negative half. Plus x over x is 1. Okay. And look over here. What kind of integral is this? Indefinite. No numbers. So my final answer will be blah, blah, blah plus c. Remember, for definite integrals, you don't need a c. All right, integral of 1 over x, natural log absolute value of x. Okay, and by the way, side note, remember 1 over x can be thought of as x to the negative 1. So when we had the power rule, remember we had the power rule, right? We said x cannot be negative 1. I can show you that. Page 403. Integral of x to the n dx. Let's see, erase it. That one there. X to the n plus 1 over n plus 1 plus c. N is not equal to negative 1, right? Because then you're dividing by 0. Okay, so what do I do if I do get x to the negative 1? Well, remember, x to the negative 1 is the same as 1 over x. So if you see x to the negative 1, treat it as 1 over x, and then hopefully you would say, oh yeah, 1 over x, that's my ln absolute value of x plus c, right? So this is ln absolute value of x. This is power rule. Add 1, x to the positive 1/2, divided by a half means multiply by 2, plus x, plus a constant. Okay, x to the negative 1/2, add 1, negative 1/2 plus 1 is positive 1/2. Divide by 1/2 means times 2. Okay, clean it up. You should never leave your answer with a 1/2 or negative 1/2 exponent. Change it back to square roots. So ln absolute value of x plus 2 radical x plus c, final answer. Okay, if the integral has a variable, it is still indefinite. Good question. You technically don't call it anything. I think you're probably asking about fundamental theorem of calculus part 1. Okay, so it's not considered definite or indefinite for stuff like this. I think something like 59, 61, 63. Those are different. So they're not considered definite or indefinite. So definite, I think of definite numbers. So it's a different category. But yeah, that's a good question. All right, so let's see, where was I? 13. Integral of sine x plus sinh x dx. All right, now you can see right below me, so it's too late, but pretend you don't see it. What's the form of the answer? And how do you know the form of the answer? You look over here. You pretty much ask yourself, are there numbers or are there not numbers? And yet not variables, as was asked. Okay, no numbers, indefinite integral. Answer is blah, blah, blah plus c. If there are numbers, the answer has a real number, right? So this one evidently is whatever, 55 over 63 or whatnot. Okay, so if there are numbers here, I guess one way to memorize it is if there's numbers here, the answer is a real number. If there's no numbers here, the answer is not a number. It's going to be blah, blah, blah plus c. Okay, so integrate. Integral of sine, negative cosine. Careful, we're not asking for the derivative of sine, which is cosine. We're asking for an antiderivative, integral of sine. What function is there whose derivative comes out to be sine? It's negative cosine. And sinh and cos are very easy. They're derivatives of each other. Therefore, they're antiderivatives of each other. So final answer is negative cos x plus cos x plus c. Check, what's the derivative of this, right? Derivative of negative cosine is negative sine or sine. And derivative of cos is sinh, and derivative of any constant is 0. So we're good. '15 is a little bit tricky. I'm going to use an identity from trig. There's a trig identity that said 1 plus tangent squared of theta is equal to secant squared theta. Okay, 1 plus tangent squared equals secant squared. If you want to put that on your cheat sheet, you may. Now I have 2. That's okay. You can rewrite 2 as 1 plus 1. 1 plus 1 plus tangent squared theta, right? There's still 2. And then I will put these together, 1 plus tangent squared theta, and make that secant squared theta. Now we're good. All right, so if I integrate with respect to theta, integral of 1 d theta is theta. Okay, so this names the variable. If it's at x, right, then I would put x here. If it was w, I put w. Since it's theta, it's got to be theta plus. And now the integral of secant squared, I know is tangent because the derivative of tangent is secant squared. So theta plus tangent theta plus c. Okay, and then 17, integral of 2 to the t, 1 plus 5 to the t dt. So this is, again, a situation where you don't really like bases that aren't base e. Base e is the nicest. Base 2, base 5, base 10, there's a little bit extra stuff you got to do to it. Okay, it's a product. However, there's no such thing as a product root. Multiply it out. So distribute 2 to the t times 1 is 2 to the t. 2 to the t times 5 to the t is 2 times 5 to the t. That's one of the properties of algebra, right? So it is 10 to the t. Again, 2 to the t times 5 to the t. You could think it's like that, right? 2 times 5 to the t. It's almost like you can distribute the t, 2 to the t, 5 to the t. So it's 2 to the t plus 10 to the t. All right, and you look at the answer. Again, the reason for it is we're going backwards. Okay, so suppose I ask what's the derivative of this? The derivative of 2 to the t is 2 to the t times ln 2. Therefore, I want to integrate 2 to the t divided by ln 2, right? It's just a backwards. Integration and differentiation are opposite operations. Plus, what was the derivative of 10 to the t? 10 to the t ln 10. Therefore, the integral is 10 to the t divided by ln 10 plus c. Okay. All right, then 25. There's a reason why I'm jumping back and forth. I do want to jump back and forth between definite and indefinite integrals so you can recognize which form we have. Okay, 25 integral from 0 to 2, 2x minus 3, 4x squared plus 1 dx. Okay, so again, before I go on, what will the form of the final answer be? What will the final answer look like? There's a number here, a number here. Definite integral. So after you integrate, both the definite and indefinite integrals, you have to integrate. Indefinite integral plus c. Definite integral, by the fundamental theorem of calculus part 2, you don't need the plus c. Okay, if you want to get really technical, you could put the plus c. You're just wasting your time. It's unnecessary. So I don't want you to put it. It's unnecessary. Then you plug in the top number, plug in the bottom number, and subtract. So your final answer should look like a real number. Okay. All right, it's a product. Something times something. What should I do? Multiply it out. There is no product root. There is no quotient root for integrals. Okay. So again, when you get to Calc 2, you can look at a product and say, oh, sure, why don't I just do the product root? Or you're going to see a quotient. You might say, why don't I just do the quotient root? Very simply, there is no product root for integrals. There is no quotient root for integrals. Okay, so you have to do other tricks, other techniques for finding integrals. Again, for derivatives, very straightforward. For a product, you can just do the same thing, right? F g prime plus g f prime. For a quotient, something divided by something, you can always do the same thing. Bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the square of the denominator, right? Not so for integrals, right? So you have to do some other tricks. So again, major topic of Calc 2 is what do you do to integrate products and quotients. This one, just multiply it out. It's a polynomial. So FOIL, right? That times that is 8x cubed. That times that is plus 2x. Yeah, I've decided to put it in order. X cubed, x squared, x to the 3. Okay, that times that is negative 12x squared. And negative 3 times 1 is negative 3. Okay, so now it's straightforward. I integrate. So please understand, regardless of whether I had the 0 or the 2 or not, you still integrate the same, right? You're still going to go 8x to the 4th over 4 minus 12 x cubed over 3 and so on, right? The difference is if you didn't have the numbers here, your final answer would be blah, blah, blah plus c, finish. Well, simplify the fraction. Now you have to do more work after you integrate. Don't put the plus c, plug in the top number, plug in the bottom number, and subtract. Okay, 8x cubed, integrate, 8x to the 4th over 4. Minus 12x squared, minus 12x cubed over 3. Integral of 2x, that's like 2x to the 1. 2x squared over 2, x squared. And the integral of negative 3 is negative 3x. Okay, do not need the plus c. Okay, the funny looking s straightens out, moves to the right side, 0 and 2. Okay, so a little bit of cleanup. That's 2x to the 4th minus 4x cubed plus x squared minus 3x. How can I check that? Take the derivative. What's the derivative of that? 8x cubed. What's the derivative of that? Negative 12x squared. What's the derivative of x squared? 2x. What's the derivative of negative 3x? Negative 3. It works. Okay, fortunately, and by the way, this happens a lot. Quite often when you plug in 0, you get 0, right? Put a 0, 0, whoops, 0, 0, 0, it's 0. So it's going to be minus nothing. So the only thing of substance is plugging in 2. So 2 times 2 to the 4th, 2 to the 4th is 16, minus 4 times 8, plus 4 minus 6. Okay, this comes out to be 32 minus 32. Cancel out. 4 minus 6, and then minus a nothing, of course. So final answer, negative 2. Remember, it's okay for an integral to come out to be negative 2, which evidently means whatever the graph looks like, it spends more time below the x-axis than above the x-axis, especially in terms of areas, right? I can tell right away. When you plug in 0, it's negative, right? Plug in 0, that's what? Negative 3 times 4, 1. So it's negative. But when I plug in 2, it looks like it'd be positive. When I plug in 1, it'll be negative and so on, but whatever. Okay, just more time below the x-axis than above the x-axis. Okay, 31. Integral of x times cube root of x plus 4th root of x dx. Okay, so I'm going to distribute and treat these as fractional exponents. That's x to the 1/3. That's x to the 1/4. By the way, side note, but anytime you see the 0 and the 1, you should be happy, right? The easiest numbers to plug in mathematics are 0 and 1, because quite often the calculation's simple. Now, x is like x to the 1, right? So x to the 1 times x to the 1/3 is x to the 1 1/3, 4/3. X, or x to the 1 times x to the 1/4 is x to the 1 1/4, 5/4. All right, so we know what to do. Power root. Add 1. X to the 7/3 divided by 7/3 means times 3/7. X to the, add 1. X to the 9/4 divided by 9/4 means times 4/9. Go from 0 to 1. They're both nice. I have to do a little bit of work with the 1. So plug in 1. What's 1 raised to anything? 1, right? Cube root of 1 is 1. 1 to the 7th is 1. Same thing there. So that's 1. So there's 3/7 minus 4/9. What's 0 raised to the 7/3 or 9/4? What? 0. Right? So 3/7 plus 4/9 minus nothing. So common denominator is 63. 3 times 9, 7 times 9, 27. And let's see, 9 times 7, 4 times 7, 28. 55 over 63. Okay, 33. Integral from 1 to 2, x over 2 minus 2 over x. So they just kind of flip this one, I guess. Definite integral. There are definite numbers right here. Okay, so since there are definite numbers, my final answer is a real number. Okay, now x over 2, treat it as half x. Now you see 2 over x. Well, you know how to do 1 over x, right? So what do I do with 2 over x? Pretend it's 2 times 1 over x, like a coefficient of 2 or negative 2, I guess. Right? So x over 2 means half x minus 2 times 1 over x. So coefficient is a half. So 1/2 x squared over 2. Remember, x is like x to the 1. Minus 2 ln absolute value of x from 1 to 2. And let's see, clean this up a little. That's 1/4 x squared, or x squared over 4 minus 2 ln absolute value of x from 2 to 1. All right, plug in 2. 2 squared is 4. 4 over 4 is 1. Minus 2 ln absolute value of 2. But what's the absolute value of 2? 2. Minus, plug in 1. 1/4 minus 2 times ln absolute value of 1. Absolute value of 1 is 1. And natural log of 1 is 0. So this is all gone. Okay, so I have 1 minus 1/4, that's 3/4. So final answer, 3/4 minus 2 ln 2. And there we go. Okay, what time is it? I wasn't going to go that much longer. Pretty much close to being done with what I wanted to do. 37. 1 plus cosine squared theta over cosine squared theta d theta. It's a quotient. Can't do the quotient root. So do something else. In this case, something else is just divide. So 1 minus cosine squared secant squared. Cosine squared divided by cosine squared 1. So there we go. Okay, integral of secant squared tangent. Integral of 1 d theta theta. How can I check? Take the derivative of this. Derivative tangent theta, secant squared theta, derivative theta is 1. Funny looking s, moves over to the right side, straightens out. Okay, plug in pi over 4. Tangent pi over 4 plus pi over 4 minus plug in 0. Tangent of 0 plus 0. Okay, from trig, tangent of 0 is 0 plus 0. So this is nothing. Tangent of pi over 4, tangent of 45 degrees, you might recall is 1. 1 plus pi over 4 minus nothing. Final answer is 1 plus pi over 4. All right. I was just going to set you up with 59, and maybe that's all the time we have. 59 is kind of an unusual problem. I may not be able to finish it all today, but I can develop it tomorrow also. Problem 59. The velocity function in meters per second is given for a particle moving along a line. Find the displacement and the distance traveled by the particle during a given time interval. So V of t is 3t minus 5, t between 0 and 3. So what's going on here is a little bit subtle. Okay, if you're on a number line, okay, positive is considered moving to the right, negative is considered moving to the left. Okay, now I notice if I plug in 0, right, you get negative 5. Particles moving to the left. If I plug in 3, 3 times 3 is 9 minus 5 is 4. Particles moving to the right. So the particle switches direction somewhere in the middle of the problem. And notice the words displacement and distance. Okay, displacement is how far I am from the beginning. Okay, so by way of illustration, let's say I'm here. Okay, if I go somewhere out this way and then I come back, the displacement is 0. Okay, I'm back home, so to speak. Or you go out for a jog, you go jogging, you go somewhere and then you come back home, your displacement is 0. Your net result from where I started. That's not the distance, obviously. You obviously got some exercise. Okay, so if I start somewhere, if I move somewhere and then come all the way back, the displacement is 0, but the distance is clearly positive. Okay, so please distinguish between displacement, how far am I from my original spot, and distance. Now, if you're only going one direction, okay, so if I'm only going that way and I never turn around, then displacement and distance are going to be the same. Okay, but if you go somewhere and then turn around and go back, then they're not necessarily the same. Okay, so 59, let me just show you what I have over here. I drew a little picture of this function. Going from 0 to 3, right? I plugged in 0, get negative 5. Plug in 3, get 4. Then I said, where does it touch the x-axis, or technically the t-axis, which means set this equal to 0. 3t minus 5 equals 0, simple algebra, 5/3. Okay, so here's the picture. 0, negative 5, 5/3, 0, 3, 4. Okay, now, so the rest is simple geometry. I'll let you work that out on your own. Okay, you know how to find the area, 1/2 base times height. You know how to find that area, 1/2 base times height. The displacement means you take the positive area and you subtract the negative area. Okay, over here, that means you have a positive velocity. Okay, so for positive velocity, you're moving to the right. Negative velocity, you're moving to the left. Okay, so you first move to the left. Now I know, I'm not sure, you might get the mirror image of me, because I know sometimes when you look at Zoom, you might get the mirror image, so it might be oriented differently. So I'm moving to the left, but if I go to the left, you might think I'm going to the right, but I'm going to my left. If I go to the left, that's negative. Then I turn around and go to the right, that would be considered positive. The displacement will be this positive area above the t-axis, subtract the negative area. The distance means you just add both areas. Okay? So if I start running, this way, and I turn back around this way, I'm running quite a bit of distance, right? Even if I come back to home, 0 displacement, but obviously you're huffing and puffing and you're getting, you got some exercise, right? So it becomes just a geometry problem. Figure out this area, figure out this area. The displacement will be this area minus this area. For the total distance, it's the absolute value. So you just add both areas. The answer will be that plus that. Okay, so it's just simple geometry now. find out that area, and go from there. I see we're just about out of time. Okay, so let me check the chat. Otherwise, we're done. Anybody else have a question? Yeah, if anybody joined late, please put your name in the chat now so I'll get you for attendance. Let me look back at the questions. Yeah, I think I'm caught up from there. Okay, any last questions? Otherwise, we're done for today. All right, that'll do it for today, folks. So everybody have a good day, and we'll see everybody tomorrow. Okay, bye, everybody. Have a good day. See you tomorrow.